So we're here at Ultimet with Gary, the Technical Director, and we're going to be learning about how Ultimet manipulate materials to actually form them into different shapes and sizes.
The machine we got behind us is a conventional press brake. This model here is a 3 metre long, 175 tonne press brake. So we can do any gauge material from very thin, 0.6s, 0.7s, up to maybe 15 millimetres thick with the correct tooling. We have the upper beam, which holds a punch tool, and what that will do, that will come down into a V'd bottom tool. Obviously you put your material in between and that will create your fold.
So basically, flat sheet goes into the machine.
Correct.
Like you've said, you then have the top that comes down,
That's it.
the bottom receptor,
Yep.
female part, male and female, and then it bends
And it will bend whatever's in between.
Is it only one bend you can do, or?
We can do several bends. A few limitations with these machines is that getting tight folds together, getting them past the tooling. They're very clever. You would draw in your profile that you require and the machine will work out its own sequence for you.
So when it comes to actually folding materials, I'm guessing any material?
Yeah, we can do aluminium, basically any metal will go on this machine. Anything that's pre-finished. So anything from a grain stainless steel, for example, a mirror polish stainless steel, will always come with a plastic coat on the sheet itself, but the neoprene just offers that little bit of extra protection that it doesn't break through and ruin that finish on the fold.
What's the most common sort of product or thing you fold?
There is no common product really. It could be anything from a very basic angle. It could be a folded tray to clad something. It could be complex little brackets. Absolutely anything can go on this machine.
When it comes to actually folding something, are there any limitations in how deep a fold can be? If you put something in and it comes up, does it ever hit the top of the machine?
Yeah, that is the only limitation with these machines, is that you're limited by the tooling that you have for it. You have different styles of top tools which have necks in them, but it's all totally down to, like you say, the material not clashing anywhere.
One of the most common things I see when we're out on site and looking at different things is you get radiuses.
You do.
On
Correct.
the material and the corners and everything.
That's it, yep.
It almost seems the thicker the material, the bigger the radius.
Correct. So for example, if it was a 1mm material, we would fold that on an 8mm V. The top tools are normally very standard, something like a 1mm radius on the tip, and that will be your internal plus the thickness of your material. So for example, that will give you sort of a 2-3mm radius on a 1mm sheet.
So when it comes to architects, designers, or someone trying to consider folding materials, is there anything they need to be aware of or they should look at to think about when drawing and designing things?
Architects are very good at wanting almost the impossible. Like we said earlier, the clashes on toolings and things like that. We do have ways around that, which we're going to move on to shortly, I believe, which will be to score fold things, which eliminates that radius you've been talking about and gives you much more scope on the profiles that you can actually achieve. Ultimet invested about a year and a half ago in a V-groove machine. Now, what a V-groove machine will do, it will actually cut a V where the fold needs to be on the back of the material. What this will do, it will cut a V 2/3 of the way down and therefore create a weak point and a sharper corner for where that fold will be.
So basically, when you say V-groove, I'm imagining it grooves.
It does.
the V
You
out
would
of
load it in, it would score all the way down the back of your material to the depth that you've set in the machine, and that will be the base of your fold.
So when doing a V-groove, is there much cost implication against just folding standard on press brake?
Obviously there is an additional operation putting the V-groove in, so it is more costly. But when you look at, you can make a 1mm piece of sheet look like a 10mm thick piece of sheet. The material saving is huge. So for architectural, for the look, much better.
I presume the other way, which you could get a true 90 degree, would be guillotining two pieces and welding the inside.
Together. Yeah, that's right. Yep.
Why not one over the other?
The main thing would be the time to actually do that. You're literally talking minutes to score fold and do a fold on. If you was to guillotine, weld, just the heat distortion going into that piece of work that you're doing. If it was a long strip, for example, you would have to stagger your welds. As less heat as possible, before you know it would go like a banana. And then you've got the whole cleaning as well. You would need to then grind off that weld, refinish your outer surfaces. From a cost point of view, much cheaper and neater to score fold.